Thanks everyone for joining. My name is Amber. I'm a community growth lead. I work a lot with the marketing and engineering team to create content and material around what we're doing here at Arise and with our open source tool, Phoenix. I'm very happy to have on our community paper readings, Shuaichen. Shuaichen, would you mind giving an introduction?
Yeah, sure. Hi, everyone. I'm Shuaichen Chang. I'm a research scientist at AWS AI Lab. And before this, I was doing my PhD at The Ohio State University. So my research is about natural language question to structured data, including like database and tabular data. So yeah, I'm very happy here today, and I'm excited for our discussion.
Excellent. All right. Well, Xiaochen, you mentioned you had some kind of background information that you're going to start with, and then we can get into the paper and kind of the second, I guess, paper that is coming out on the next work and the applications, because I know you mentioned, working in industry, like being interested in the applications of your research.
Yeah, sounds good. So let me give a brief introduction. And let me see. Let me share my screen. Okay. Mm.
And then anyone that has questions while you get that up, you could ask your questions in the chat, in the Q&A, or even in the Arise community Slack, especially if you have questions that we don't have time for during this live session. Xiaochen's in the Arise community Slack and can answer those afterwards.
Yeah, I will give about, let's say, 5 or 10-minute introduction, but you can interrupt me if you have any questions, or we can do the QA part at the last. Okay, cool. So let me start it. So the paper is called How to Pump Large Language Models for text-to-SQL. So we focus on the study in zero-shot, single domain, and cross-domain settings. So text-to-SQL model is a component in a larger like natural language interface to structured data system. So this is pretty much what my PhD work about. So basically in such natural language inference system, we have a human user. The human user can interact with data by asking natural language questions. And the data in here can be like table, relational database, or even some charts images. And the text-to-SQL model is a model behind the NLI agent, which is able to understand user question as well as the data and generate appropriate response. So look at the detail of what the text-to-SQL model does is it takes the natural language question, which is called NLQ here, as well as a relational database. So text-to-SQL model take both of them as input and output a SQL query. The SQL query will be executed against the database to obtain the final answer. So in this case, database is about WTA players and games. So the question is like find the name and rank of the 3 youngest winners across all matches. So by translating this natural language question to the SQL query, which will be executed against database, we will have basically 3 names who are the 3 youngest winners across all matches. So in the past, not few years, maybe just 1 or 2 years, we can see how fast large language model develop, in almost every applications. So on the left, we have this. Yeah. So on the left, we have this is the performance on our widely used text-to-SQL dataset called Spider. On the left, we can see some fine-tuning based model which train on 7,000 examples. And on the right, we can see the performance of some large language models with in-context learning, which means the model is not particularly trained on the training side of the dataset, but just with either 0 or few shot pumping. So usually less than 32 demonstration examples. Those methods can be comparable, even slightly better than the like fine-tuning based method. So those study basically try to enhance larger model performance with different approaches. Some of them do demonstration retrieval, some do some advanced intermediate reasoning steps, such as train of thought stuff. So however, they also use different strategy for constructing the prompt tags of the database and demonstrations. We'll show how they did later. So this leaves us two slight drawbacks. One is it's hard to compile to work on their main contributions or their prompt constructions, right? And the second, the future work still has to explore the effective prompt constructions for the text-to-SQL task, which is so-called prompt engineering.
Mhm.
So our
And
work
Xiaojun, the models that you show here, do those provide their prompt templates so that you could at least compare them like by eye?
yeah. So the problem is like the prompt in general are different in every work if they do in
Mhm.
content learning. But in here, I would say the two part of the prompt or two part of the contribution in their work. One is what they propose about how to retrieve demonstration that will improve the model performance. But beside that, there's something fundamental for every text-to-SQL paper or work is how you convert a structured database into an unstructured text into the large language model. Because we know the large model are trained for like predicting next word. So they only accept a sequential input instead of like a structured input. So even a lot of work focused on the first part, the second part under study, like how basically convert the structure database into the unstructured text.
Okay, got it. Thanks.
So this is our focus in this paper. So our goal is to study how to represent the structure. Basically, I'm trying to say here, the structured database in the unstructured prompt.
Mhm.
We study three common scenarios. You may question like what the difference of them, but we'll go to them a little bit later. And we also want to study how to construct the demonstration for the cross-domain setting. So the zero-shot setting is the most straightforward. So imagine the model is just say the model is a well-trained SQL expert. You can just give the model a database and a question and simply expect the model to return the SQL or the answer of your question given the database. So in this part, the prompt text contains the database information, including database schema, database content, as well as instruction. Instruction usually pretty simple. Let's say what we expect the model to do given the input. And the actual input questions, which is in here, like how many high schoolers are there. This is a database about high school students, I believe. And we expect the model to generate a SQL query that be able to get the answer from the database. So this is the most straightforward setting. And in this case, we have a different way to represent the database information because like how to represent the structured information into unstructured text. So apparently the most important thing about database is what table is there and what column are there in each table. So this information is always necessary in almost every work. But some work also found a different way to represent some information. Besides the basic table information, we have the information, the relational database contains the information across multiple tables through the foreign key, basically. So we can see, oh, the friends in the front table, student ID is a foreign key referring to the ID in a high schooler. So such information can be also included in the database prompt. And moreover, we have some other paper, paper proposed that we can represent all this information in a simple create table format, which is basically using a SQL query to create such database. And this will be the input of the large language model to represent the information in the database. So besides database schema, we have the database content. And database content, we can include pretty much like some people do, let's say for every table, we list 3 different rows about the table. So this we can also use like insert row using SQL query to do that, or just simply give a small table. Or we propose to do that in column wise to increase the model understanding of what the possible value in each columns. So to sum up to what we found in the zero-shot setting is we found basically the schema, table schema is definitely always necessary, but adding the table relationship, which is represented in foreign key, we consistently see model can outperform the prompt that now using the relationship. So which shows the relationship is very helpful for the model to understand the database. And moreover, we found adding the database content could be even more beneficial, but the model doesn't favor all type of ways to for providing such database content. So now let's move to the single domain setting. So people say like, oh, since zero-shot setting already works so well, why we need a single domain setting? The single domain, basically, you can imagine you have an application that you know what possible query has been, or what query has been asked in the past, right? So knowing those questions that has been asked in the past will definitely help the model to understand the database or know what questions are more likely to be asked in the future, and therefore to improve the understanding of future questions. So just same as the zero-shot setting, we just have one more different thing is the demonstrations. The demonstrations are the pair of natural language questions and SQL queries. And this demonstration usually insert in front of the test question. So we found after having the in-domain demonstrations, we found the model performance can continue enhanced when the number of in-domain demonstration increase. So this definitely show like how powerful the demonstration is. And moreover, we find the models relies less on the table relationship when we have more examples. So remember on zero-shot, this is 2 part of lines, there's a gap in here. But when we have just 16 examples, this basically merge. So the model doesn't need the table relationship from the database prompt. They can learn that from the in-domain examples. However, we found such in-domain example doesn't provide enough information about the database content. So the large model still like the prompt that contains the database content directly. But by having some in-domain example, the large model is now sensitive to the choice or the choice of prompt representation for the database content.
And just to clarify on the table here, okay, so that's the Codex language model, and then the using ChatGPT. This is probably a future question, but have you compared this to like GPT-4, Llama 2, like some of the larger models that tend to do really well with context like this and like structure?
Yeah, that's a good question. We actually experimented with some open source model, which actually now doesn't perform as well as ChatGPT even. So we see the
Okay.
same, but I personally have never tried GPT-4 on this experiment. You can see there's a lot of experiments here, so it could be pretty expensive to run this with GPT-4. Yeah, but in general, my personal takeaway is that such information about the database is not something that after model become more powerful, they can naturally get. They have to be exposed to the information of this specific database to perform better on those tasks. So I believe that in-domain demonstration is always necessary. Even the model can be even more powerful and developed way better in the future.
Okay. Yeah, that makes sense. And then in terms of the like the accuracy here for how correct a query is? Are you comparing like a SQL query that you or someone on your team has written that is correct and runs and executes compared to the query that has been generated by this LLM? And then how do you get like that like 82% accuracy, for example?
Yes, yeah. So the accuracy is based on execution result. So we actually have a database contain a lot of rows or information inside the database. So given a SQL query, we can execute a SQL query to get a set of answer to the question. So we compare to whether a SQL query is correct. Then we use that query to execute that against the database to get a set of answer. We compare that with the Oracle answer to determine whether the SQL query is correct. Because the same intent can be writing in SQL query in many different ways, right?
Mm-hmm.
It's
Mm-hmm.
hard to say a SQL is correct, but just look at the surface tokens of the SQL query.
Yeah, for someone that has used SQL and has almost gotten it correct, almost gotten all the data that I need from a database. It's interesting because I sometimes, oh, it returned data, I must have gotten it right, but then there's one area or like one line that didn't work and you just didn't get that amount of data.
Yeah, yeah. So this is actually a pretty interesting research track, just using the execution result to help the model to correct itself in the future prediction. Yeah.
Mm-hmm.
So yeah, similar to what you found, right? Oh, I almost correct. So like I want to figure out what part I missed and how I can improve on that. Yeah. So, but unfortunately, this is not including this work, but it's definitely a very good direction to explore.
Right. Okay. Awesome. Thanks.
Yeah, cool. So then we move to the last part of this work, it's the course domain setting. So you may want to know like what is the course domain setting for? So basically, course domains text-to-SQL assume that the database doesn't come with any annotated example. In this case, you can imagine the user upload a table or relational database, and other user may ask a question about it. So in this case, the model is not like nobody annotate any questions or SQL query about the database before. And this is very similar to the zero-shot setting. But the difference why people work on that, because people find by using the database and text-to-SQL example from another domain or another database could actually enhance the model performance. So it's not as good as in domain, but it's definitely better than zero shot. That's why a lot of people explore in this direction. And in this case, we construct a prompt using the demonstration. The demonstration are the natural language question and SQL pairs you can see here, but they are corresponding to a different database than the test database. So we ideally want to answer the question better about the database, the high school database, but we can use another database, here's the track database, and use the question about this database to improve the performance of the language model on another database. So first of all, we want to know whether these are helpful or not, right? If it's not providing any benefit, why don't we just switch back to the zero-shot setting? So actually good. So by comparing to not using any example, which gave you about like 73 accuracy, then having some auto-domain demonstration could improve the model performance. But we do see here, we consider in the auto domain demonstration, we consider different number of database. Each database can come with different number of example. The example are natural language question and SQL query pairs. So the question here we see, like by having like given a certain number of like database example for database, we say that having more database will first improve the performance, but it sort of has a threshold for the model codecs. And then after we cross this threshold, the model performance started to drop. So it's a little bit surprising because by having more a database in the demonstration, we always add a database ahead of the existing one. So if the model doesn't like the specific demonstration, it can simply ignore that. So at least the model should be able to maintain its performance when we given longer context or more demonstration example. But we find the performance of model start to drop significantly when we have more examples. So we analyze this phenomenon and found out it's actually related to the contact length, how many tokens we have in the contact. So for Codex, it has the maximum contact length provided by OpenAI is 8,000. We found it's about, after the demonstration was about 5,500, the performance of the model started to drop. We also experiment this thing with ChatGPT 16K context. So the model supports 16 tokens in its context. And very interestingly, we found the model have a similar performance the phenomena after the context course about 11K. So if you think about it, for two different models, all about 70% of the context. So like only 70% of context, maximum context is actually useful for the text-to-SQL demonstration. It could be true for other models, but I haven't experimented that myself. But at least for these two models, all from OpenAI, we see the similar trend. This
So
show
Xiaotian,
up.
so just the one example per database, that's when essentially everything like you're saying after that you get that improvement, but then it just kind of stops adding to the improvement as you add more and more examples.
Yeah, I believe if the model has like unlimited long context, so
Mm,
we will see this probably going up and eventually it should be similar to those lines above them, above this one.
mhm,
But since the database schema is very long, has a lot of tokens, so it's very easy to cross let's say we have an immiscible line here. It's very easy to cross that to make the performance drop before it actually improve more.
mhm. That's that's still really, I still find that like pretty impressive compared to so that's like 3 out of every 4 queries still getting it correct, even with like one example per database. Okay. That
Yeah,
was better than my accuracy when I was first querying databases with SQL.
yeah, but those models use a lot of training data, so it's
Yeah,
not.
yeah.
Yeah.
True.
Yeah, I think in general, after we found this in text-to-SQL tasks, I also found other people talk about the similar phenomena in different tasks or different setting, that the model may not be able to leverage the full context in different tasks. So yeah, I think it could be general, but at least in this task, we found this phenomenon exists in multiple models. So now let's back to the question we care about from the beginning, like how to construct the database prompt. So we found that the table's relationship and content is still important, even we have out of domain demonstration. So by comparing these 3 different part of the tables, we can see it's still better with the relationship and contents to provide the best performance, even with a lot of out of domain examples. It makes some sense to me because like think about the relationship of the tables and database content. They're very database specific. So even providing some example from other database, the model may not able to, like the model could leverage or understand what a relationship means, or what a database content means, but it still have no idea about what this database has in terms of the relationship and database content.
Hmm.
Yeah. So overall, I really hope like this work can be like a handbook or something for future study. Like when they want to work on a text-to-SQL task with in-context learning, they don't have to explore all different combinations of how to construct the database or how to construct the schema, content, and stuff. So we can spend less time on those things and focus on how to improve the general capability of text-to-SQL, for those models.
Yes, no, I agree with that. And then the other thing I was just going to ask, because someone in community was mentioning that they tackled a similar problem. I think this was a while ago, right when Transformers and NLP was really taking off, probably like around 2018 when these tasks were first becoming like, oh, you don't just have to write a rule-based system from text to SQL, you can actually use NLP for these problems. And a lot of people thinking, oh, we could get to 100% accuracy. It's pretty structured, and we're still not there. I'm curious, what do you think is like the biggest thing blocking from that like 90 to 100% performance?
So in my opinion, if you look at how much the in-domain example can help, so
Hmm.
I believe like for the model, right now it's still not 90, but believe them what the model like maybe let's say 3 years or 5 years later, right? We have GPT-10 or whatever, this
Yeah.
more powerful. Yeah, it could possibly do pretty well, like understand the question perfectly well. But something is missed in those data is like what a database means. Because
Mhm.
some database you can assume is like a well designed, well format. So this one
Mhm.
perfect without any questions, anything, you understand what's going on in the database, right? But in industry, I know that a lot of database or tabular, they have some, let's say, arbitrary tokens at the column, right? They have some, let's say, have the internal knowledge to name some column or tables. In that case, since your data is private and hopefully not trained by any other models, and then why can we expect that model understand a specific database? So basically it cannot. So in that case, let's say we have a column, instead of like a name or grade or ID, we have a column like a B32X, right? This random token there. So we don't really know what's going on in that column. So we definitely need some, for example, the in-domain examples or some explanation to that column for the model to understand. So I feel like from 90 to 100 is not about how we input the model. It's like no human can do that without any further information either. So in that case, I feel like the next step and maybe like how we can easily add some we call domain knowledge into the model, like by providing either give the domain knowledge along with this database, or we find other way to like say generate some example using the domain knowledge so that the model could understand the database better first and then answer the question about the database.
Okay. Yeah,
Yeah.
that makes sense. I buy it.
Well, it's actually pretty close to what we're trying to do in the next one. If we have time, we can briefly talk about that.
Yeah, I think we have 15 minutes left. And yeah, pretty much all of the images that you used on here were the ones I was going to ask you about in the paper. So yeah, if you want to go to your main paper takeaways, we could talk about what you're working on now in applications.
Yeah, but before that, do we have more questions about this work?
Let's see. Okay, so I think we got them all. Yeah, I think we got them all.
Okay,
Um, I will have Sarah check in the community Slack, but from what I see from the chat, they've been answered in the questions that I've asked.
okay, cool. So let me talk about the next work. So basically, the next work is inspired by what makes the in-domain demonstration so useful, right? So this is another work, which is at MIP this year. So called Selective Demonstration for Course Domain Text-to-SQL. I personally really like the course domain setting because it assume that you don't have any example. Well, it doesn't rely on any actual annotated in-domain example. So in this case, the database provider can be a non-SQL expert and database user can be a non-SQL expert. So basically anyone can use the system if we create a good cross-domain text-to-SQL model. So, but before we understand cross-domain, we want to understand what's the magic part in the in-domain demonstration. So this is what we found in the spider dataset, the same as what we talked about before. There's another dataset called CargoDBQA, which is also have text-to-SQL, cross-domain text-to-SQL data, but this has a little bit more challenge than the spider data. So we can see that the zero-shot citing the model is Codex model, perform pretty okay on spider, not that good at CargoDBQA. But having in-domain example can significantly boost the performance on both data sets, right? So this from 76 to 84. Here you can go from below 30 to all the way 70. So we want to know what actually the in-domain demonstration did here. So the two questions we care a lot about here is what are the key factors within the in-domain annotated example that contribute to the performance improvement? And the second is, can we harness the benefit of this in-domain example without actually using the annotation? So we consider three different spikes within the in-domain demonstration example. The first is the text-to-SQL task format and knowledge. It's the general knowledge about this task. And the second is the in-domain natural language question distribution. And the last is the in-domain SQL query distribution. So we have seen that providing the task knowledge is pretty easy. We can just simply use the out-of-domain example to do that. So by having the out-of-domain example, we do see the performance increase in both data sets, but definitely not comparable to using the actual in-domain example, right? So we know, okay, the task knowledge is beneficial, but it's definitely not sufficient. However, we do a simple play on the data. We create a mismatch natural language question and SQL queries in the demonstration. So we find the model's performance. Model basically could not leverage this demonstration for even the in-domain. So that show us the task knowledge, even though not sufficient, that's still necessary in this task. And then we study the in-domain NLQ and SQL distribution. So for NLQ, we use the actual natural language question with the SQL query that are generated by the Codex model in the zero-shot setting. In this case, the model is exposed to the actual natural language questions, but the SQL query is predicted by itself, so it doesn't bring any actual knowledge. Similarly, we can give the model, say, the actual SQL query, but using the natural language question that are predicted by itself. So in each setting, the model exposed to one knowledge, but not aware of the other. So we found that by having the SQL distribution, which is using the actual SQL, but predicted natural language question, the model could learn almost the same as using the actual in-domain examples. So it's very close in spider, slightly larger in CargoDBQA, but much better than all the other settings. So from this analysis, we kind of know maybe the SQL query about the in-domain, about a database basically, can help the model understand something about database. So in the future, the model could answer the question better about the same database. So the second question is like, okay,
We do
now
have a question, Shuaichen, from our community member, Greg, asking about, there's been a lot of push towards vector databases. Do vector databases fit in at all to, I guess, fit into the work that's being done here with SQL, because we're using a lot of relational databases compared to these now new vector databases that are being used in these large language models. That sounds like a complicated question, Xiaojun. I don't know if you have thoughts about this, I for like where vector databases might fit in.
You mean the vector database in this setting?
I think he meant yeah, the using vector databases as opposed to relational databases, which is I'm I'm not sure if SQL would be used for vector databases. It's kind of more like where, where SQL comes in. I don't know if they would be used together. I don't know if you've come across
Yeah,
seeing.
so I didn't think about exactly the same scenario because pretty much SQL query was designed for a relational database. But for vector DB, I feel like maybe large model can do that pretty well as well, but in a different way. Because
Mhm,
the easiest way that we use the larger model is just simply give a text input, right? We can definitely fine tune that with like embedding, prefix tuning or stuff. But the easiest way for people who don't understand AI or machine learning, the way they use is just simply just give a natural language input. So in that case, the relational database may just easier to embed it into the larger model.
mhm, mhm.
Yeah.
Yeah, yeah,
But
for the structure.
maybe we will have some larger model that designed for like vector DB and stuff, that we will have the training data to train such models.
Interesting. Yeah, that's it. That's an interesting question from our community. Thanks, Xiaojun. Yeah. So getting back to these, so these two main questions here, um, how how do you think they're demonstrated?
How can I think about what?
How do you think they're demonstrative? So we see like selective demonstrations for the two types of the in context learning and the text to SQL. So these are the two main questions that are these the two main questions that you're trying to solve?
Yeah. So we sort of have seen the answer for the first question. And I'm quickly going to the second one, how we can harness the benefit of the in-domain example.
Okay, perfect.
Yeah. So, well, even though we know that, okay, we found the in-domain SQL distribution is important, but it's not always available, right? You have to annotate. So first of all, you have to know what question the user may actually ask, and then annotate those questions into a SQL query. Then you can say, okay, I can use those to improve the model performance. But for, let's say, a cold start scenario or other cases, like we don't have the resource for such annotation, how can we still get the benefit, or how can we leverage the funding here to create a better model? So for here, my solution is pretty simple. So we try to synthesize some data about a specific database without seeing any actual examples. So we first synthesize the SQL query by using some out-of-domain SQLs. We use those out-of-domain SQL to provide, sorry, here, yeah. So here, basically what we're trying to do, we use a synthetic query. But since that example may not always be correct, especially after the query, we also want to generate some natural questions. So the questions may not be that natural, may not align the SQL query perfectly. So in this case, it may not provide the correct text-to-SQL knowledge when we have seen that the correct text-to-SQL knowledge is necessary for the model. So that's why we propose to use the hybrid source of demonstration containing both out-of-domain demonstrations and in-domain synthetic demonstrations. So in this work, we contain two parts, like we need to study. The first is how to retrieve the good out-of-domain demonstration example. So we basically, I won't go to the detailed algorithm, but we basically trying to retrieve the random example that are similar to the test example, so that a large model can learn something from the random example and use the knowledge into the test example. So we first do a SQL prediction, and we use the initial SQL prediction to do the retrieval. And for in-domain, we first need to synthesize the in-domain data. We sample some SQL query by using the SQL template from out-of-domain examples, out-of-domain SQLs. And then we translate that SQL into NLQ. And then we have a verification stage, which is pretty tricky. So we first translate some SQL query to a natural language question. And then we translate NLQ back to a SQL query. So if the two SQL query had the same execution result, then we can assume that the translation was correct in both directions, and then we keep this example. So after we have the in-domain example, we do some retrieval. Similarly, we want to retrieve the example that's similar to the test question. So we do a maximize coverage retrieval here. So basically, we found that by using the hybrid source of demonstration, we found with 3 different language models, Kodak, ChatGPT, or Llama. Llama is an open source model, the other two are from OpenAI closed source. So we found that our proposed framework can outperform the all the baseline models, as well as the method that use only using out of domain or only using in domain examples. So yeah, in general, I found this pretty the proposed methods are pretty useful for multiple text-to-SQL data sets with multiple large language models. Yeah.
Okay.
Yeah. So I know we don't have a lot of time, so let's what question we have. I don't know. I can't really see the chat right now, but
And then I think we have a few responses. Before we depart though, I did want to mention if you are in the Bay Area, Arise is running a hackathon. Sarah is going to drop the link for that, but it's an in-person Bay Area hackathon around large language models. So if you're interested in that, come meet the team and come check out the event. There should be a lot of players kind of in the LLM space in this like SF hacker mansion.
I'm
Xiaochen,
New York based now. I know like Bay Area definitely has more like tech vibe than New York.
yeah, and there's a lot of in-person events there. We do a lot of virtual events at our highs, but yeah, now there's more and more in person, especially the LLM events. I know I'm getting jealous of all the events that are in there right now because there's not as many on the East Coast as there is over there. But we did get some discussion around the vector database. A lot of people I see are having to leave because I think there's only 60 seconds left, but a lot of people are thanking you, Xiaochen, for the information, the talk. I think a lot of people have been trying to do something similar with the GPT-4 models, just providing, I guess, so one member of our community said that just by adding in a few examples in a prompt from doing like the prompt engineering really helped for a particular database that they were using to create SQL queries. So it's
Right.
great seeing more work being done in this area. And then someone from community mentioned that Nitin mentioned that basically that SQL, he agrees with you, like SQL would just not be as appropriate for a vector database because of the space relations that the relational database is built on and how SQL inherently operates. And so that's very interesting to see there. We are out of time. Xiaochen, thank you so much for going through your paper, your latest results. Those are great, great performance scores. And I can't wait to see, when it's just hitting 100 every time for these examples. And I'm also interested to see how this will apply to more industry topics. But thanks everyone for joining, and I hope you all have a great rest of your week.
Yeah, thank you for having me.
Thanks. Bye.